Welcome to part 2 of questions and answers on particle model of matter. We're doing exercise 13 from the book. Let's get right into it. Number 1, arrange the following materials in order of increasing density. These are lead, cork, water, zinc, and ice. So the one with the least density would be cork, then ice, then water, then zinc, then lead, because lead is very heavy. Number 2, study the following sketches or photos and answer the questions that follow. We have an iceberg, some balloons, a thermometer, thermometer. There we have some lines for electricity, some factories, a heater. 2.1. Which sketches, photos are applications of density? That would be A, B, E, and F. 2.2. Which sketches or photos are applications of diffusion? That would be E. Which sketches or photos are applications of expansion and contraction? That would be C and F, because it's heat, and D. Complete the table. Everyday applications. 3.1. Olive oil and vinegar are poured into a container as a salad dressing. The oil will float on top. What is this an example of? It's a properties of density that differs. 3.2. When a wire fence is strung on a hot day, the wires are not pulled tight. Why? Because of the expansion. This is an example of expansion because wires expand when they are hot, and when they cool down again at night, then they will be tighter. 3.3. Air freshener is sprayed in the bathroom. What is this an example of? This is an example of diffusion. 3.4. A pipeline for the transport of different types of fuel from the coast is an example of what? Yes, density differs. Number 4. Sandra wants to do a practical investigation after school after her teacher's explanation of the particle model of matter. She adds a little Oro syrup to a glass of water. 4.1. What does she observe? The syrup mixes with the water and the particles move between one another. 4.2. What happens if the water is stirred? It mixes faster. 4.3. What will happen if warm water is used instead of cold water? It will also mix faster. 4.4. Why will the syrup and water mix faster when it's stirred or heated? The particles have more kinetic energy and can move faster and therefore mixes faster. Number 5. At a birthday party, the people notice that the balloons that are hanging in the sun all burst after a while. The balloons hanging in the shade, however, did not burst. Explain why this might have happened. This will be like 4 marks. So the temperature of the air in the balloons that are in the sun is higher, and the particles therefore have more energy and can move faster. This means that they collide against each other and cause a high pressure. The balloon will expand due to the great pressure, but it can only expand to a certain maximum volume before it bursts. The particles in the shade have less energy, and the pressure is therefore much lower. Number 6. Why does a rugby ball or soccer ball get more inflated when it is filled with more air? The more particles there are in a container, like the rugby ball, the more collisions there will be and the pressure will continuously become greater. The ball therefore becomes harder due to the greater pressure. Number 7. Why does a hot air balloon rise? The air particles gain energy and they move farther apart. This makes the balloon expand. The warmer it gets, the farther apart the particles move, making the density of the air inside the balloon less than the air outside, which makes it rises. Number 8. Why is a layer of pollution in the air more visible in the winter than in the summer? In winter, the air is cold and the particles do not move as fast as in the summer. This causes the layer to remain close to Earth and do not move upward. Rain also plays a role in areas with summer rain because the particles dissolve in the rain. But for us here in the Western Cape, we have winter rain, so it helps a little. Number 9. Use the particle model of matter and the properties of the state of the matter to explain the following questions as comprehensively as possible. A syringe is filled with air. With the end closed off, it can be pushed in. Explain using the particle model of matter why gases can be compressed. So, the spaces between particles of a gas are very big, and the particles can therefore be pushed closer together, which means that it can be compressed if they're close together. If it is compressed further than the limits of the gas, it will become a liquid. So if you compress a gas enough, it will become a liquid. I don't know about air. What happens when coffee powder is dissolved in water? Number 10. The coffee particles will break down into smaller particles and move in between the water particles, and there it mixes. 11. Why will coffee powder dissolve more quickly in warm water than in cold water? The particles of the warm water have more energy and therefore move more. If the particles move more, it can mix better and faster and move in between each other. Number 12. Why can air pollution be a problem even if you don't live next to a factory? So the air particles in air pollution are mainly gases, and gas particles move continuously. And the pollution particles can mix with the air particles, and the wind can easily spread these particles over very large distances, so it can travel very far, even if you don't live too close. Number 13, this is the last one. Why will a heater heat up an entire room in winter? How does that work? So the heat or the energy is transferred to the air particles, and the air particles are gases that move fast. That way, the particles with more energy, the warmer particles, spread through the whole room. And that is it for this.